Namaste student. Today we are going to see operation on irrational number. So for class 9. Now in operation we have addition, subtraction, multiplication and division. So today we are going to see all of them. So first we will go for addition of two irrational number. We'll take two irrational number and we'll see the addition, how to do. I hope that you people know like term addition. Like if I give you x plus x, then it will be 2x. If it is 3x plus x, then it is your 4x. So when you have x like term, then only you can add. If you have unlike term like this, you cannot add. Your answer will remain same. You cannot say that 3 plus 1, 4xy like that. No, you cannot do. But for multiplication, you can do. The same concept we are going to apply for irrational number. Instead of x, whatever root irrational number will get, that we need to take. And we'll see that same root over number is there or not. If it is there, then we will add. So here we have like first one, if we, for example, we'll take here like 3 root 2 plus root 2. So here you need to take as x, that means 3x plus x. So 3x plus x means 4 root 2, that is 4x. Next, if we proceed for another problem like 4 root the 7 plus 11 root the 7 plus 12 root 7. Sorry, not 17. Okay, take it 17 here also. If we take 17, then what will we going to get? As we can see that root 7 are like. So we are going to add, that is 11 plus 4, 15. 15 root 7. And here we are getting 12 root 17 and it will remain same. We will not going to add. Why? Because here you can see that both are different. That means this type of problem. If you have x and y, you cannot add. So similarly here, if your root numbers are not same, then you cannot add or subtract. For subtraction also same rule applied. But for multiplication and for division, we do not follow like that. Okay, we'll see this thing. Now next, see number one. Check another example. 2 plus root 3. This is one problem. Plus 7 plus root 3. So in this case, what we're going to do, we'll take the like part together. Like here, you can see that 2 plus 7. And here we are getting root 3 and plus root 3. That means 2 plus 7 is 9. And 1 root 3 will give you 2 root 3. This way we're going to add. Okay. Now if there will be minus symbol, no problem. If we go for the minus symbol, if we take here minus, we will get here 0. Why? Because these two will cancel each other, we will get 0. That is 9 plus 0 is what? 9. This will be your answer. Now we will proceed for subtraction. In subtraction, what we are going to see? Data will change here. In subtraction, we will go for here minus. That means 3 minus 1, that is 2. If we go for subtraction here, in this case, if we write here, what we are going to get? 4 minus 3. See, 4 not minus 3. 4 minus 11. 4 minus 11 will be minus 7 root 7 plus 12 root 17. If there will be minus, no problem, keep it to minus here. Will not going to add. Why? Because unlike. Okay. For this already we have seen. Now we go for multiplication. We'll see the multiplication part. Let's see. The multiplication, before starting multiplication, we need 3 rule to know. Let's see that 3 rule. What are those? First one is root over AB give you root A into root B. This is one rule. Another rule, root over A by B can be written as root A by root B. And the third one, that is root A whole square will give you A, root over A square will give you A, and root A into root A will give you A. All are same. We're going to apply this whole concept in multiplication and division. Now we're going to see. Okay. So let's see one by one. First problem, like multiply, question will be like that. Multiply 2 root 3 and or by 7 root 3. You need to multiply. How are you going to multiply? Take it here. We have 2 root 3 into 7 root 3. So you can see here that 2 into 7, 14, and root 3. Right now only I told you root 3 into root 3. That means root A into root A will give you A. That is root 3 into root 3 will give you 3. So that means we will get here 3, and our answer is 14. This way we need to multiply. This is a single term, that means one term. Okay. Now we are going to see that binomial term is two term. Two term problem we are going to see how to multiply. Okay. And for that we need to apply one more rule. Okay, first we will go for general and then we will use the formula to get our answer. Let's see here. General rule we will follow for multiplication. So whenever you take this type of multiplication, if you get one more like 7, so you can multiply with the 7 and get your answer. Okay. Now next problem. If we take 3 root 7, multiply with 7 root 3. Both are not same. So how are we going to multiply? The way we have done A plus B into C plus D. Like we take here A and then C plus D and B, C plus D. The same concept, whatever we have learned in class 8 for algebraic multiplication will apply here. Let's see. That means first our target number 3. We'll take 3 here and the whole thing here. 7 plus root 3. Next, plus root 7 and the bracket 7 plus root 3. Now you multiply here 3 into 7, 21 plus 3 into root 3 will get 3 root 3. You cannot multiply inside and outside part. If both are in inside, then only you can multiply. We'll see here in this case. How? See here 7 into root 7, 7 root 7. But here 7 root 7 into root 3 will give you root 21. Why? Because right now only I have shown you that root AB can be written as root A into root B. That means if we have root A into root B, then we can convert this part into this. So here we have done here root 7 into root 3, we are getting here root 21. Now you find your like and then you add, but you can see that all are unlike term. You cannot add. That means it is your answer. Okay. Now, if we'll see for formula, we'll go for the formula now. This is our general method. You can apply this general method to find the multiplication part. Okay. Now, if the data would be like this, instead of this, if we get here 3 minus root 7 like that. So shall I multiply like that? Yes, you can multiply like that. No problem. You will get the answer. But this is one formula comes from. Okay. What? A plus B, A minus B. That means we can apply A square minus B square. Now if you say that also, first I want to see that if I apply this general method, shall I get that one? Yes, definitely we will get it. Check here. We'll see here. Okay. So 3 in the bracket 3 minus root 7 plus root 7, 3 minus root 7. Now 3 into 3 is 9. 3 into root 7, there's the minus, plus minus minus, 3 root 7. 3 into this plus 3 root 7 minus root 7 root 7. Already shown you. Root 8 into root 8 will give you 8. That means root 7 into root 7 will give you 7. Now you can see here that plus 3 root 7 minus 3 root 7 cancel each other. We'll get here 9 minus 7 and our answer is 2. Now if you apply the formula, let's see that. If you apply the formula, our calculation will reduce. 3 plus root 7, 3 minus root 7. That means a square minus b square. And you will get here 3 3 are 9. And already I have shown one formula, that is root a whole square will give you a. That means root 7 whole square will give you 7. So here we are getting. Have you seen? This is quite simple and take less time. So we'll apply this one. Now many students are thinking that, sir, how do you say that this will give you 7? We need to know. Is there any general formula to get that type of things? That means root over a and the whole square will give you a. Let's check here. There's a method for that one. If we take root a whole square, that means root a means what? Root a means a to the power half. If nothing, that means half. Okay, if it is cube root of a, then we write here a to the power 1 by 3. If it is fourth root of a, we write 1 by 4 a to the power. So here, now we can write here a to the power half power 2, and we know that power of powers multiply, that means a to the power mn. So here we are going to multiply a to the power half into 2 and 2 cancel each other, a to the power 1 is a. So this is your procedure to get a root over a square, that means root over a whole square will give you a. Now we'll apply here for division. Okay, we'll see the division part. Let's see here. Very simple part we will see. Like division is nice. We'll take the small, and the next video we're going to see the rationalizing part, and then we'll go for that one. Okay, but not now. So here the division, like if I'll give you divide 30 root 7 by 5 root 3. Take it like that. Then what we are going to get? 30 root 7 by 5 root 3. So here 3, 5, 3, 6, we are getting 6 root 7 by 3. Why? Because we know that root 7 and root 3 will give you root over 7. You can keep your answer like that. No problem. This will be your answer. And if data here change, if it is 14, like this, root 14. Okay. So what will be our answer? If it is root 14, you can see what's the little changes will be there. How? Here we have 30 root 7, and this denominator we have here 5 root 14. And we know that 14 can be written as, see here, root over AB can be written as root A into root B. But here you can see that root 14 is here. That means root 14 can be written as root 2 into root 7. That why? Because root 14 means 2 into 7. That will break into root 2 into root 7. So we'll write here root 2 into root 7. Why? Because it's that root 7 cancel each other, and we are getting here 5 6, that means 6 by root 2. 6 by root 2 we are getting. But this, if your denominator is irrational number, then it is non-standard number. We need to convert this one in a standard form, and to convert in a standard form, we rationalize the denominator. In the next video, we are going to see how to rationalize, but here we are going to make it a standard form. To make this standard form, what we are going to do? We multiply numerator and denominator by root 2. Why? Because root 2 will give you 2. So we will get here 6 root 2 by 2, and now this will cancel 2, 3, and our answer is 3 root 2. You can see that that is standard answer we are getting. So division is very interesting because here we are applying your rationalizing the denominator concept. Okay, I hope you people have